Now that we've braced the cripple wall with plywood and bolted the cripple wall to the foundation, there's one more thing we need to do. We need to make sure that the house stays attached to the top of the cripple wall, otherwise it'll slide off. So let me show you how that works. So here you can see the braced and bolted cripple wall sitting on the foundation. As an earthquake force comes again and pushes underneath the house as the ground moves, you can see how the house is starting to slide on top of the cripple wall. As it continues to slide underneath the house moves even more. As you can see on the right, it can fall off completely. So what we use is pieces of steel, also called connectors, which you'll see photographs of in a minute. The floor connectors are the last part of our cripple wall retrofit, and let me show you how they work. So this is the floor that you walk on. And then this is the floor framing that supports the floor you walk on. And then this sits on top of the cripple wall. And then this right here is the cripple wall itself. Now, an earthquake comes, we can't have this floor framing slide on top of the cripple wall. Naturally, we'll get damaged like we saw before. So here you can see what happens. Earthquake forces come here, and it slid a little bit. It slid, I don't know, 8 inches or so. We can't have that happen. So what we do is we install these right here called shear transfer ties or floor connectors. And that way, when the earthquake force comes this way, that force goes into the top of the cripple wall, and because the cripple wall is braced with plywood and it is bolted to the foundation, it can't move. Here you see 2 floor connectors. This right here is the top of the cripple wall. Now this floor connector here is called a type E connector. And the way this works is this nail and then this nail and then this nail, they nail into this board right here. Then there's some other boards, nails that come down this way. And when they come down this way, they attach to the top of the cripple wall. And that way when the floor tries to move, it goes into this type E connector, and then that goes into the top of the cripple wall, which is what we want to have happen. Now this works exactly the same way. This is a different part of the floor here. When it tries to move, it goes into this type F connector and into the top of the cripple wall. And now that we've got our cripple wall, you know, if they were covered with plywood and then it was bolted at the bottom, we would then have a complete what's called a shear wall. A shear wall is something that resists earthquakes. It's made out of bolts, it's made out of floor connectors, and it's made out of plywood.